discuss the eccentric shear. So ano nga ba ang kahibahan ng eccentric shear sa direct shear? So pag sinabi kasi nating direct shear, yung applied load natin is nag-a-act dito sa ating center. So andito yung direct load natin. So pag sinabi nating direct shear, yung applied load natin acts on the centroid in our considered group of bolts. So, ito yung bolts natin. So, yung direct shear, yung applied load act on the centroid. So, let's say, load acts here at the center of our group. So, ito yung centroid natin. This will be now considered as our direct loading. So, ito. So, yung magiging reaction natin on each bolt is equal. Kasi yung load natin is acting at the center or at the centroid of our group of bolts. So, yung magiging reaction natin dito, let's say, this is R, yung applied load natin at our centroid, yung magiging reaction natin dito is equal to the P, yung load natin, over the number of bolts. So, in our figure, yung number of bolts natin is equal to 4. So, each bolt is equal. So, you just have to divide it by 4. However, when we consider naman the eccentric shear loading, yung load na i-carry nung bolt natin is not equal. So, looking at this figure, yung load natin na P is located at a distance of E. So, ito yung distance natin. Tinatawag natin dyan yung eccentricity. So, denoted by letter E. So, why do you think bolt stresses is not equal in eccentric shear? So, they are not equal because when we applied load, yung P, when we applied load at a distance of eccentricity, we will develop now a torsional moment dito. So, magde-develop tayo ng torsional moment dito sa centroid ng ating bolts. So, the outermost bolt or the farthest bolt will now have the maximum stress. So, hindi pare-parehas yung stress ng ating bolts unlike doon sa direct shear. So, ang analysis kasi dito, we will move our load, yung load P natin, sa centroid ng ating bolt. So, dito siya sa centroid nag-a-act wherein the load is called direct loading. So, ililipat natin yung P natin dito sa ating centroid. So, if we move our load in our centroid, we will have now or we will develop now a moment. So, magkakaroon tayo ng moment kasi meron tayong load, meron tayong eccentricity distance. So, pag ililipat mo yan, magkakaroon tayo ng moment dito sa ating centroid. So, magkakaroon tayo ng equivalent or may katumbas yan na moment. So, yung ating bolt ngayon, may additional na ngayon na load due to this moment. So, magkakaiba yung ating stress sa ating bolt. So, the farthest, yun yung pinaka-critical or yung the farthest bolt or yung the outermost bolt, yun yung pinaka-critical na nagkikerry ng pinakamataas na stress. So, ganyan siya. So, yung torsional moment natin dito, let's say this is M, yung M natin is equal to P times E. So, yung P multiply the distance E or the eccentricity. So, what if we have a load of, let's say yung P natin is hindi vertical. Let's say yung P natin is inclined. Yan yung P natin. So, paano natin itra-transfer yung ating load dito sa ating centroid? So, pag meron kayong inclined na load, pinakamadaling gawin ninyo is you have to convert the inclined, kunin nyo yung vertical component niya and yung horizontal component ng ating load. Saka nyo is siya i-moment dito sa centroid para mas madali. So, yung horizontal natin, yung px, meron tayong y, and then meron tayong vertical component yung ating load, i-multiply natin siya sa ating eccentricity na E. So, ganyan. So, when we have here direct loading. So, meron tayo dito ng direct loading. So, yung direct loading natin, yung P natin is nasa gitna ng ating centroid. So, nasa gitna ng ating centroid ng group of bolt. So, yung direct loading natin is just equal to P over N. So, yung P, yung load natin over N, yun yung number of bolt. So, ganyan lang yung gagamitin natin to solve for the direct load. And we also have here the load due to the moment Rx and Ry. So, meron tayong Rx, yung Tx that is equal to yung T, yung PE, ito yung torsional moment natin, yung T that is equal to the load times the eccentricity. I-multiply natin siya sa Y for pag ang kinukuha natin is Rx and pag kinukuha naman natin yung Ry natin, yung load due to the sa horizontal, ita-times natin siya sa distance of x. So, ano yung x? Ano yung y? Yan yung distance nung bolt, yung center ng bolt sa may with respect to ry and rx. So, yan. So, meron tayo dito. So, yung torsional moment natin, if counterclockwise, yung load per bolt natin, load due to the moment per bolt natin is the direction nung load due to moment natin is against nung sa direction nung torsional moment natin. So, we have here notations, yung P, yung load natin, yung N, yung number of poles, yung T, yung torque or moment which is equal to load times eccentricity, and yung X and Y natin is the distance of centroid from Y and X axis. So, yan. So, we have here an example for problem 1. So, the figure shows a connection. A load transmits 220 kilonewton load acting at an eccentricity of 220 mm. So, the load transmitted to the column by the plates with a 422 mm diameter rivets. So, we have to calculate the maximum shear stress in the rivets for the equivalent vertical force alone acting at the centroid. We also have to calculate the maximum shear stress in the rivets for equivalent moment alone acting on the centroid, and we have to calculate the maximum shear stress in the rivets. So we have here given in the figure yung ating bracket. So we have P 220, meron tayong eccentricity 220, meron din tayong distances of bolts from the centroid. So we have to analyze one side of the bracket. So, pag ito kasi yung column natin, so yung magiging connection natin, so yan yung magiging connection natin. And then, dito yung rivets natin or bolts natin, ito yung column natin. So, itong 220 is yung both sides nung ating bracket. So, pag inanalyze natin itong problem, i-consider lang natin yung one side of the bracket. So, ito, meron siyang 4 na bolt dito sa side na ito. Meron din siyang 4 na bolt dito sa side na ito. So, kailangan nating i-analyze lang yung isang side ng bracket. So, pag inanalyze natin yung isang side ng bracket, yung P natin ngayon is i-divide natin ng 2. So, yung P natin is 110 kilonewton. Magiging 110 kilonewton na siya. So, yan yung gagamitin nating P. So, for the first required, we have to calculate the maximum shear stress in the rivets due to the vertical force alone. So, we have here, for letter A, we have stress due to the direct load alone. So, we know that it's stress. So, ang stress natin is the load divided by the area. So, ito yung hinahanap natin. Shear stress due to the direct load alone. So, yung P natin is due to the direct load. So, ano yung area natin? Yung area ng ating bolts. Isang bolts. So, paano natin kukunin yung P? Hindi yung, ang P na gagamitin natin is hindi yung 110 kilonewton. Kasi yung 110 kilonewton, i-carry nung 4 na bolt yun. So, para makuha natin yung direct load, so let's say, pag andito yung RD natin, yung direct load natin, i-divide natin yung given na P na 220, 200, yung 110, kasi isang bracket lang yung i-analyze natin, yung load na na-transmit over the number of volts, that is N. So, yung RD natin, yun yung P natin. So, the RD is equal to yung P over number of volt, which is 4. So, yung P natin is 110. I-divide natin ng 4. So, yung isang volt, magke-carry siya nung 27.5 kilonewton na load. Isang volt yan. So, pinaghati-hatian ng 4 na volts yung 110 kilonewton. So, yan yung gagamitin natin. Yung RD, yan yung gagamitin natin sa ating stress formula. So, substituting yung value ng RD, yung isang volt, which is 27.5 kilonewton, or that is equal to 27,500 newton, divide natin siya sa area. Kasi ang stress is equal to load over area. So, yung lalabasan yan, so yung FP natin, 27,500 newton, i-divide natin siya sa area ng isang volt kasi isang volt ito, load ng isang volt. So, ang area ng isang volt, that is pi over 4 times yung diameter natin, which is 22 squared. So, using your calculator, ang masasolve natin na value dito is equal to 72.34 Newton per mm squared or 72.34 MPa. So, ito na yung magiging sagot natin for letter A. That is the shear stress due to direct load alone. So, for letter B, sabi naman na sa letter B, we have to calculate the maximum shear stress in the rivet for the equivalent moment alone. So, moment lang din alone. Hindi din natin i-consider yung direct load. So, for letter B, so, for letter B, due to the moment, yung stress due to moment alone. So, paano natin i-compute yung stress due to moment alone? So, yung meron tayong eccentricity, meron tayong P, which is yung 110 yung gagamitin natin, which is yung isang side lang nung bracket. So, how to solve for the uh, value of the stress due to moment alone? So, alam natin na ang formula ng stress is equal to the load. Ito, yung load natin dito is due to moment alone, yung P. Yung P natin is due to moment alone over the area. So, stress is load over area. So, ano yung load natin? Ito yung isosolve natin na load due to moment alone. And ano yung magiging area natin? Yung area ng isang bolt, which is pi over 4, 22 squared. So, para makuha natin yung maximum shear stress in the rivet for equivalent moment alone, kailangan muna nating isolve yung P doon sa ating bracket, doon sa ating bolt. I-carry nung ating bolt that is due to the moment. So, yung P natin due to the moment, where's that? So, yung bolt natin, magkakaroon na tayo ng, pag nag-moment tayo dito, pag nagkaroon tayo ng ating moment dito, magkakaroon din yung ating bolt ng moment. So, magkakaroon siya ng moment. So, kailangan nating kunin. So, for 1 bolt, naka-incline yung ating direction, kailangan natin kunin yung equivalent Rx and Ry nung ating forces. So, we need to solve for the Rx and Ry. And then, kukunin natin yung resultant na R. So, yung resultant na R, yun yung ating load due to moment alone. Yun yung isa-substitute natin dito sa formula to solve for the shear stress. So, in solving Rx and Ry, in the previous slide, meron tayong formula for Rx that is equal to, the formula for Rx is equal to the Ty over the summation of x is squared plus y squared. And of course, yung Ry natin, yung T times x over the summation of x squared plus y squared. So, ano yung magiging T natin? Yun yung magiging moment natin, yung T. So, for the value of T, yung moment natin that is equal to load over yung distance eccentricity natin. So, ito. Sorry. So, pag transfer kasi natin yung load dito, magkakaroon tayo ng moment. Kaya i-multiply natin yung P, which is 110 kilonewton, times the eccentricity, which is 220 mm. So, yung lalabas na value natin for T is equal to 24,000. That is 24,200 kilonewton mm. So, yan yung magiging moment natin dito, which is 24,200 kilonewton meter. So, meron na tayong T. Yung value ng Y natin, meron din tayong value ng Y. So, pare-parehas yung distances ng 1, 2, bolt 1, 2, 3, and 4 sa X and sa Y. So, yung Y natin, yung centroid, papunta dito sa bolts, dito sa taas man or sa baba, parehas na 100. So, pag magkakaiba, kailangan natin kunin yung farthest kasi yun yung pinaka-critical. So, yung Y natin, meron tayong 100 dito sa may centroid. Doon sa may centroid yung distance. And then yung x naman natin from the centroid up to the most critical bolt. So pare-parehas lang yung bolt 1, 2, 3, 4. Yung x natin is 100. And then, kailangan natin kunin yung summation of x squared plus y squared for us to solve yung ating rx and ry. So, to solve for the summation x squared plus y squared, kailangan natin kunin yung summation niya doon sa may centroid. So, ito. So, yung x natin, ito yung x natin which is 100 doon sa may centroid. And then, isa, dalawa, tatlo, apat na bolt, pare-parehas yung x niya na 100 papunta sa centroid. And pati yung y natin, yung bolt 1, bolt 2, bolt 3, bolt 4, pare-parehas ang distance y na 100 doon sa may centroid. So, pag magkakaiba yan, kailangan yung isa-isahin na i-add. Since pare-parehas yan na 100, yung x natin, pati yung y natin, you just have to write 100 x, that is 100 squared, plus yung y natin, 100 squared din, times, kasi sabi niya summation, so ilang bolts? So, i-multiply natin siya ng 4, kasi apat na bolt ang merong x distance na 100 from the centroid at apat na bolts ang merong y distance na 100 from the centroid. So, pag magkakaiba yung x and y niya dito, isa-isahin nyo siyang kunin. So, isa-isahin nyo siyang i-add or i-summation. So, ito kasi pare-parehas yung x, pare-parehas yung y, kaya minultiply ko na lang ng 4. Pero pag magkakaiba yung distances niya, kailangan nyo siyang isa-isahin i-add. So, using your calculator, masosolve natin yung summation of x squared plus y squared. That is equal to, that is 80,000 mm squared. So, yan na yung value natin ng summation x squared plus y squared. So, meron na tayong value ng t, meron na tayong value ng summation x squared plus y squared. Makukuha na natin yung value ng rx. So, you just have to substitute yung value natin. So, yung rx natin is equal to value of ty, which is 24,200 kilonewton meter. Yung y natin, which is 100 mm, yung distance ng bolt from the centroid, over, ano yung magiging summation x squared natin? That is 80,000 mm squared. So, using your calculator, you just have to input the values and makukuha natin ng value is 30.25 kilonewton. So, yan pa lang yung value ng ating x due to our horizontal, yung load natin due to the horizontal. Kailangan din nating isolve yung ating ry. So, yung magiging ry natin is t, which is 24,200. Yung x natin is 100 pa rin, over the summation of x squared plus y squared is 80,000. So, ilalagay natin yung 80,000 dito. So, yan yung ry natin. That is equal to 30.25 kilonewton. So, meron na tayong value ng rx, meron na tayong value ng ry. So, if we have here yung bolt natin, ang kinukuha natin is yung resultant kasi yung torsion natin, pag ganun, diba, ito yung centroid natin, ito yung magiging load ng bolt natin due to the moment. So, that is our R. Ang nakuha natin is Rx, which is 30.25, and yung Ry, which is 30.25. So, how to solve for the value of R? So, kukunin natin yung resultant that is equal to Rx squared plus Ry squared nung ating bolt. So, yan, para makuha natin yung value nung ating load due to the moment alone. So, yung magiging R natin, substitute natin yung value ng Rx squared, which is 30.25 squared plus 30.25 squared. Ang makukuha nating value is equal to 42.78 kilonewton. So, yan yung magiging load due to moment alone. So, hindi pa ito yung sagot kasi ang hinahanap natin is the stress. Ang hinahanap natin sa ating problem is the stress. So, ito pa lang, load pa lang yan in kilonewton. So, balik tayo doon sa unang formula natin that is stress is overload over area. So, yung load natin is yung load due to moment alone, which is 42.78 kilonewton, or you can convert that as Newton. That is, pag ginawa yung Newton, that is 42,780 Newton. Over the area, which is pi over 422 squared. So, area nung isang bolt ito. So, solving the values, ang ating shear stress due to moment alone is equal to 143.29 MPa. So, ito yung sagot natin for letter B. Our stress due to moment alone. So, ito yung sagot natin. So, we have 143.29 MPa. So, that is our answer for letter B. So, for letter C, yung letter C naman natin, we have to calculate the maximum shear stress. So, pag sinabing maximum shear stress, magkasama na yung stress due to the moment and due to our direct load. So, for letter C, yung maximum stress, magkasama na yung moment, stress due to moment, and stress due to load. So, for example, pare-parehas yung distances ng bolts natin. So, pare-parehas lang sila na sila yung i-consider natin. So, pag kinonsider natin yung isang bolt, for example, so pag hindi pare-parehas yung distances, yung pinaka-critical is yung pinakamalayong bolts kasi yun yung unang mag-fail or yung farthest na bolt doon sa ating centroid. So, pag ito yung bolt natin, ang nakuha natin, meron tayong value na nakuha noon sa ating letter A, meron tayong value na nakuha due to the direct load. If maalala nyo pa, that is equal to, that is due to direct load, meron tayong 27.5 kilonewton. And yung load natin due to moment, ito yung load natin due to moment. Yung X, which is 30.25, meron din tayong Ry na 30.25. So, meron tayong due to moment. Ito, due to load ito, direct load. Ito, due to moment, which is 30.25 kilonewton. And yung Rx natin is equal to 30.25 kilonewton. So, kailangan natin pagsamahin na yung direct load and our moment para makuha natin yung maximum shear stress. So, solving for the value of our load, yung resultant load natin, so meron tayong Rx, meron tayong Ry. So, that is, ito yung resultant load natin, that is equal to the Rdx squared plus r dy squared. So, ano yung magiging r dx natin? Isa lang, yung 30.25. So, that is squared of 30.25 squared plus ano yung y natin? Dalawa, yung due to the load and due to the moment na ry. So, that is 27.5 plus 30.25 squared. So, solving for our maximum load, that is equal to 65.19 kilonewton. So, load pa lang yan. Hindi yan yung hinahanap natin sa problem. Kasi ang hinahanap natin sa problem is yung shear stress. And ang alam natin that shear stress is equal to R, the load over the area. So, yung maximum shear stress natin, maximum din yung gagamitin nating load, which is maximum load natin due to both moment and direct load is equal to 65.19 kilonewton. So, we have to multiply it by 1,000 para maging newton over the area. So, ano yung area ng isang bolt? That is pi over 4, 22 squared. So, yung magiging value natin dyan, if we input that in our calculator, ang makukuha natin is 171.5 Newton per mm squared. So, ito na yung magiging sagot natin for letter C. The maximum shear stress in our bolt. We have 171.5 MPa. So, yan yung magiging maximum shear stress natin.